If you're not using plugins already in your web development, I think it's time you start. Using plugins and plugin architecture can really help make your application extensible, flexible, and honestly a lot more maintainable. So if you like the idea of being able to add more features to your web application without risking breaking the other parts of it, plugins are an awesome option for you to consider. In this video, I'm going to show how we can use plugins with Autofac inside of a Blazor web application, and by the end of this, you should be able to adopt this pattern for your own web applications. And before we jump over to Visual Studio, I just wanted to mention that I've had some requests to put some content together, maybe making a course around building plugins and designing plugin architecture. So I am going to be starting on that and putting some content together for it. I will be making a course, and with that said, if you want to subscribe to my newsletter, that's where I'll be announcing that first. So if you want early access to know when that's going to be releasing, sign up, it's totally free. Alright, enough blabbing, let's jump over to Visual Studio. Alright, so in Visual Studio, I've just gone ahead and created a sample Blazor web application, and I've started to make some modifications to it, and I'm going to walk through that to show you how I have Autofac set up and how we'll get plugins registered. So full disclaimer, this is totally based off of the sample app that when you walk through to create a new Blazor project, this is basically what you get out of the box. I've just started stripping some things out and adding some additional things. The first part that's going to be different is actually leveraging Autofac here. So what I've done is I've added this Autofac extensions dependency injection NuGet package. And if you want to understand just the basics of getting this working, I'll link a video above and you can go watch that and come right back here. But the first thing we're going to want to do once we have that is configure Autofac to be our service provider. And yes, Microsoft does have their own dependency injection framework, but my preference is using Autofac. I'm most familiar with it, and I really like the functionality that it comes with. So what I have on screen at this point right here is really the core part that's going to configure Autofac to be the dependency injection framework for our application. But the piece that's inside that I have highlighted right now is what we're going to use to discover and register plugins. So just to briefly explain what this is doing, it's going to check for files in our directory where we're running from, and it's going to look for any DLL that has plugin in the name. It's only going to be searching in the top level directory, and for what it's worth, this part is something that in your own application, you might want to configure to be different. So maybe you want to look in a specific folder for plugins or different folders. You might want to look for plugins with a certain name or something like that. This is totally just an example. It's not going to be perfect. It's not going to be bulletproof. The next part that we do inside here is that we're going to load the assembly from the file, and then we can register all of the modules in that assembly to Autofac. The variable CB is just a container builder, and that's part of Autofac where we're going to register all of our dependencies to that, and then the container builder will build a container which will be our service container that we can resolve dependencies from. Again, in your own production application, you might want to put a little bit more safety around line 17 here that has the assembly loading, just in case something goes wrong, and you can decide how to handle that gracefully or blow up your app if you need to. Other than that, though, there's not a whole lot else that's changed in the top level part, so I've removed the part that actually registers some of the example services and stuff that they had in here because we don't need that anymore. I think they have like a weather service and that kind of thing. I've actually replaced that with the plugin part we're going to look at, so that would probably be right after line 23 here if you're using the default application that gets created. So this is what we're replacing it with. And you'll notice that I don't have any specific plugins being registered here. And that's because I'm going to demonstrate that we can just drop plugins into the bin directory and they'll automatically get taken up when we start our application. The next thing that I want to highlight is that if we want to have plugins, we probably want to have an API defined for what those plugins can do. I didn't get very creative in this example, so I just made an iPlugin API. It just has a single method on it called getDataAsync that returns a string. Now, based on your particular use case, you're going to have all sorts of different things here that you might want to expose for plugins. And I figured there was no point in making this part complicated for demonstration purposes. I just want to show you how you can create something, and then we'll be able to register it and resolve it and then use it. You'll also notice that in the Solution Explorer, I've actually put this interface into a separate project here, and I just have it called .plugin API. And the reason I've done this is to demonstrate that when we go create another project, so a totally separate plugin library that's going to be separate from our base application, that instead of having a weird dependency where the plugin library depends on our core application, the only dependency it really needs is this interface. In your particular application, you might want to have some type of libraries or infrastructure that plugins can use, but we're just keeping it simple here and exposing one single iPlugin API that our plugins have to implement, And that way, when we go to resolve them, we're looking for all of the iPlugin APIs that are accessible to us. I do have one single implementation of a plugin called Plugin A, and there's Plugin A library that we'll look at after. But what I'm going to walk through is the core app so we can see how we're going to use plugins. And that way, when I go to show you Plugin A library, you'll understand how that's going to be leveraged. So in the core application, I have a plugin provider. So I'm going to go to that class right now. So this is super simple, and I've left out a lot of pieces here. And all that we're going to be able to do is illustrate that leveraging Autofac, we're actually able to go resolve all of the plugins, and then we just have a method called get plugins to return them. So to explain what's going on here, this is really more about Autofac usage. So what I have is an IEnumerable of iPlugin APIs, and you'll see that it's wrapped in lazy as well. So the idea here is that when we go to access the plugin provider for the first time, depending on how much work was actually required to go resolve all of the plugins and how heavy of a lift that was. So for example, if your plugins actually had work that they were doing in their constructors to initialize or something like that, all that I'm trying to do is delay when that work is going to take place. This is just a little extra thing here because if you had something like this, this would help you have your startup time be reduced a little bit in a situation where plugins could technically take time to initialize. In our particular case, that's not going to be a concern at all. But I just wanted to demonstrate that you could take advantage of something like this. You'll see that we're going from IEnumerable to iReadOnly list, and the reason that I still have lazy wrapping an IEnumerable, because IEnumerable can be lazy loaded technically on its own, is because with Autofac, I'm pretty sure it's already resolved and created the instances of the plugins if we were to just do this, but with lazy wrapping it, we're actually able to delay when those plugins will actually get created. So again, this is just a little bonus thing if you want to consider that for your own application to help with startup time. But beyond that, really all that we're doing is returning the value of the plugins for this get plugins method. So nothing really fancy here at all. But the magic is actually happening because the way we're going to register this plugin provider is that Autofac will be able to automatically insert all of the iPlugin API implementations for us. So if you're thinking about the benefit of that, it's really awesome because we don't have to manually go register plugins anywhere. It's just going to feel like it's kind of magically taking up new plugins that are available in the bin directory for us at startup time. And just to reiterate, one of the reasons that I really like plugin style architectures is that we're able to extend applications without having to modify the base application. So taking steps like what I'm showing you on screen right now are helpful in making sure that we can have this automatically resolve plugins without touching the base application. So the next part that's in here that's Autofac related is actually the Autofac module where we have to register this. And it's really simple actually. So with an Autofac module, we just need to override the load method, and all that I'm doing is registering the type plugin provider and making it a single instance. From the perspective of the core application, we don't have to do any fancy plugin registration or anything like that. We're simply just registering this plugin provider type, and then we're leaving it up to our plugins to actually go register modules for themselves. We'll get to that in just a moment, but I'm going to show you the Razor view where this information is going to be shown. So back to our Solution Explorer, if I go to Fetch Data, this is actually where the weather example was. I've just changed some of the text up here to show that it's going to be for our plugins. And I've modified this a little bit, so the view that we're going to have is going to say the count of the plugins, and the weather example had a table that would print all the weather information out, so I just changed that to be a single column that says plugin output. And what we're going to do is for each of the plugins, we're just going to call getDataAsync on that plugin. I realized after when I was creating this that getDataAsync maybe wasn't the best usage here because we can't really await things that are async inside of the Razor view. So this looks a little bit nasty. I apologize. I probably could have just made it a property to keep things simple. Or if I show you the part down here, what I probably could have done is actually made it so that it wasn't the list of plugins that we're looking at, but instead the output. But regardless, on initialized async, all that we're doing is asking the plugin provider to get the plugins. Because this part's technically synchronous, I just put a task yield in front here. So again, in an example where this was taking a long time, we'd at least have the opportunity with this task yield to allow the schedule to run something else in the meantime. So once the plugins are set, if we scroll back up, you'll see there's a null check here on plugins. So it'll say it's loading while plugins are null. And then when it's not, we'll actually be able to have this information get populated. Okay, so before I show you the actual plugin implementation, which is going to be very simple, I figured let's go run this thing, let's see what it looks like, and then I can demonstrate, after showing you the plugin implementation, just how easy it is to make a plugin work. Alright, so I'm running our sample application here, and we can see that we have this nice fun text at the top here. I've left the sample counter piece in here, I haven't stripped that out, but if we go to fetch data, that's where we're going to run our new plugin code, and we can see the title here, but this is where we're actually checking how many plugins we have, right? So there's 0 plugins because we haven't added any, and this is where we would see the plugin output, but because we have a for each loop and there's nothing in there, nothing's going to be output below it. So it's pretty boring right now, but we needed to see this first to be able to prove that when we go to add something, this will change. All right, so let's go check out that plugin A code. So in our Solution Explorer, like I showed earlier, I have this plugin A library. I'm going to go to that right now, and we'll see 2 files. We'll start with plugin A. So plugin A is super simple. It's just a class that's implementing iPlugin API, which, like I said earlier, that's the only requirement that a plugin has to implement. And all that I'm doing is returning a string here that says data from plugin A. The whole point here is that I just wanted something that would illustrate that we have something coming from this particular plugin and not something super generic. So the plugin itself is really simple, but the other piece that's going to make this work is the module for Autofac. So I'm going to jump over to that now, plugin A module. And it looks similar to the other one that we looked at earlier. So we'll have the container builder that's passed in to this load method that we have to override. I'm going to register the type plugin A. I'm going to say as implemented interfaces because it implements the interface for iPlugin API. And then again, it's going to be a single instance. So I wanted to pause for 1 second because if you're thinking about what a plugin library looked like here, we had one file that was one class that had to be the plugin itself, and then a second class that's the module to actually register that plugin. Now, something to consider in your design is whether or not you want your plugins to actually have to care about Autofac. In the example that I'm showing you right now, it would mean that every time we wanted to go add a plugin, they need to have a dependency on Autofac in order to be registered into the container. And that might be totally acceptable for your application, but otherwise, and I'm not showing it in this example, you could use something like reflection to go iterate through the assemblies, iterate through the types of those assemblies, and look for everything that is iPlugin API. At that point, you could manually go register all of those things individually, and you could build that right into the core application. But instead, all that I'm showing you here is that if we wanted to keep adding more plugins, each one of them would also need to have a module just like this. Personally, for a lot of my projects, I already have Autofac being used in plugins anyway, not just to expose the plugin, but actually internally used within the plugin. So because I already have Autofac as a dependency for almost everything I do, I don't actually have an issue with doing something like this and having a module. However, there are a lot of opportunities where when I have a lot of plugins of a particular type, it gets a little bit annoying to have to remember to manually register each one, even if I already have modules like this. So a lot of the time I will have a bit of a hybrid approach where I do have some reflection to go register types, but I just wanted to mention it because if you're watching this and you're thinking about how you might apply it, you may want to consider something like that for your plugins. All right, so to actually make this work with our core application, we don't have to change anything in the core app, but all that we have to do is build plugin A library and then take the DLL output of that and put it into the bin directory of our core app. So I'm going to go ahead and build this now, and then I'm going to take the files, copy them into the bin directory, and I'll press run again to show you what happens. All right, we're back in the sample application. Let's press fetch data and see what we get. Awesome. So the first thing we can see is that there are 1 plugins. Yeah, I probably could have put the S inside of some braces here to make it less ridiculous when you read it, but there are 1 plugins. And if we look at the plugin output, we now have an additional line here, and we can see that this is the text that came from plugin A. And I know in the recording here, I've jumped from Visual Studio. You didn't see me copy the binaries, and I can't prove that I didn't go edit the core application, but if you trust me, all that I did was I copied the DLLs into the bin directory of the core app and just relaunched it. And that is how we can extend a Blazor application with plugins. All right, so that was just a quick video for today to be able to walk through how we can have Blazor applications with plugins inside of them. Now, I know the plugin example I used was really simple. It just had a single method on it that was returning a string, but I wanted to keep it simple like that because it's going to be up to you and your application to understand what kinds of plugins you want to include. In the example we looked at, I used some techniques that would allow automatic discovery of have modules and plugin DLLs, but I did call out that each plugin in particular would also have to have an Autofac module to register the plugin itself. You can use reflection to be able to register things from other assemblies, so that's totally an option. I use it in a lot of my own personal projects, but in this example I didn't show that. We're just requiring that you have a module for each plugin. And then all that we had to do was build the project, drop the DLLs into the bin directory, and the main project actually was able to launch and take up those DLLs and show you it right in the UI. So I hope that helps illustrate to you why plugins can be super powerful in things like Blazor apps, and I hope that you take advantage of it for yourself. Thanks for watching, and we'll see you next time.